Lesson 3.08, Parallel Properties, Converses. I don't think I wrote that right, but anyway, we can get on with the lesson. Oh, goodness. I got to remember how to do all this. I haven't done it in a while. There we go. Alright, the objectives of this lesson is to use postulates and theorems about parallel lines to complete proofs. And the key term that we're going to be using in this lesson is coplanar, which means lying in the same plane. We learned that in Unit 1. The theorems that we're going to be going over are the converse of the corresponding angles postulate. And what this is, if you remember the corresponding angles postulate, and you remember what a converse is, we're just flipping the hypothesis and the conclusion. So we're saying now if two coplanar lines are intersected by a transversal and the corresponding angles are congruent, then the lines are going to be parallel. And the same works for the converse of the alternate interior angles theorem. It says if two coplanar lines are intersected by a transversal and the alternate interior angles are congruent, then the lines are parallel. And remember, do not assume that side lengths and angles are drawn to scale. Only information that is explicitly given or marked can be assumed. So we're going to be doing some more proofs. Yay! I know y'all are excited. Up here it says that the given line L is perpendicular to line T and line M is perpendicular to line T. So if you look up here, here's line T, and you can tell that these guys are perpendicular. They put the little box there. What we're going to prove is that L is parallel to M, and we're going to be using the converse postulate and theorems for for corresponding angles and alternate exterior angles to prove this. So we know that the first thing we always write down is our given, that L is perpendicular to T and M is perpendicular to T. And next, we're going to write down that angle 1 and angle 2 are right angles. And this is basically given to us up here in the drawing, but we need to go ahead and state it because it helps us prove that line M is parallel to line M without any loopholes. Now notice what I did here. Remember I told you always take a previous statement for your if and take the current statement for your then. So I wrote if two lines are perpendicular, then they are right angles. Now what you're supposed to do with this is look at your list of definitions, postulates and theorems, and properties and see what matches up with this statement the best. And after you go through there and you do some looking, you find that the definition of perpendicular is what's going to fit this the best. Because when you have two lines that intersect and form perpendicular lines, they also form right angles. And that's the best we could do there. Now then, next, we're going to say that angle 1 is congruent to angle 2. And look, see, I got rid of my if-then statement. That was kind of like doing hen scratch on the side. What I really wanted to know was it was the definition of perpendicular. So when I say 1 is congruent to 2, I put if two angles both measure 90 degrees, and see how that matches my statement 2, then they are congruent, and that matches my statement 3. Well, then I look through my list of everything we've learned up until now and I say, okay, what fits this the best? Well, you remember that, I think it's congruence postulate. There you go, angle congruence postulate. Now, I can say with confidence, since angle 1 and angle 2 are congruent to each other, then I know lines L and M are going to be parallel. And the way I say this is if corresponding angles are congruent, and if you look, angle 1 is congruent to angle 2, you look in your drawing up here and they are corresponding angles. Then the lines are parallel, and that matches my current statement. So this is what my final proof should look like. Well, I put converse of corresponding angles or postulate because I went and looked at my list. Sorry, I was jumping ahead of myself. Went and looked at my list and said, hey, This postulate that I just learned is what's going to fit this if-then statement the best. So now, this is what my final proof looks like. Okay, let's do another proof. Now this one says, and this one I got from your LMS. I looked through all the materials I have. I could not find another proof that was even similar to this one. So I went ahead and pulled this one from the LMS, but I included the if-then statements to help you better understand how it's going to work. This one says if the given M is parallel to P and N is parallel to P. So both of these lines right here are going to be parallel to line P. They want us to prove that M is parallel to N. Well, it looks like right away you'd say, well, transitive property, but you got to make sure there aren't any loopholes. So we're going to go ahead and write down our given that M is parallel to P and N is parallel to P. Then I'm going to say angle 1 is congruent to angle 12. And look here, there's angle 1, that's line M, and there's angle 12. Well, just ignore line N for a minute, okay? The reason I know this is because angle 1 and angle 12, well, let me do the if-then. I was fixing to let the cat out of the bag, I guess. If M is parallel to P and N is parallel to P, then angle 1 is congruent to angle 12. Okay? And we get that information. They kind of skipped a couple of steps, I think, or at least one step in this proof, which was probably saying that, no, they didn't. Never mind. And I figured this out because remember line M is parallel to line P? So angle 1 and angle 12 are alternate exterior angles theorem. And look right here. I put, hey, if all these lines are parallel to each other, then 1 has to be congruent to 12. And the best way that I could say that was through the alternate exterior angles theorem. Okay, this next one says, well then angle 12 is also going to be congruent to angle 10 because N's parallel to P, then 12 is going to be congruent to 10. So see how I pulled that from my previous statement? 12 congruent to 10 is my current statement. And guess what? It's the corresponding angles postulate because look, angle 10 corresponds with angle 12. And once you get really good with these parallel lines cut by transversal, you won't even have to do the if-then. You can just look at the angles and say, hey, that's an alternate exterior angle, or those are corresponding angles. Okay? So what we're going to say next, I'm going to bet, is that angle 1 is congruent to angle 10. There we go. So I took my previous statements, if angle 1 is congruent to 12 and angle 12 is congruent to angle 10, then angle 1 is going to be congruent to angle 10. And you look through all of that stuff, but hopefully you'll remember that transitive congruency property, or transitive property of congruence. I just said it a little backwards. Okay, and then lastly I can say M is parallel to N. And I put here, I just used my previous statement, M is parallel to P, N is parallel to P, and angle 1 is congruent to angle 10, then M has to be parallel to N. And wow, you're sitting here going, where do I get that information? There again, you've got to go through and look at all the information that you've learned this far and see what matches this if-then the best. And it's going to be what we just learned in this lesson, the converse of alternate exterior angles theorem. That almost looked like it could be transitive, but since they were talking about parallel and congruent, it couldn't be transitive. So it had to be the converse of the alternate exterior angles theorem. And that's what your final proof would look like. You'd take all the ifs, thens out, and that's what you'd end up with. Okay, what we learned in this lesson was that using converse of the same side interior angles theorem, converse, da 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 da. Anyway, we're going to be able to prove theorems about lines being parallel by using all those converses. When you get finished watching this video, of course, you're going to read through the lesson 3.08 in Parallel Properties Converses Part 2, complete the student guide, read up on your pages in the reference guide, work on that problem set. And yes, there are some proofs in there, but they're partial proofs. They aren't proofs that you have to do completely by yourself like we've been doing in the videos. And please, 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 before you take the 308 quiz, contact me or attend TOGA if you have any questions. And that's going to be the end of this lesson on converses. Thanks for listening.